If your Suzuki Swift is hesitating when you press the gas, it can feel like the car is thinking about it first, and only then moving. That half-second delay, the stumble, the little jerk right when you need clean acceleration to merge or overtake. And the most frustrating part is that the symptom screams fuel problem to most people, so they start mentally pricing a fuel pump or injectors. But on a Swift, and honestly on most modern small petrol engines, hesitation is often an air and spark story wearing a fuel mask. Before anything else, a quick safety note in plain language. If the check engine light is flashing while it hesitates, or the car is shaking hard like it's running on fewer cylinders, don't keep pushing it to see if it clears. A flashing light usually means active misfire, and that can overheat the catalytic converter. Same if it's losing power dramatically or you smell raw fuel. In those cases, the smartest move is to stop the test drive and diagnose, not to drive it out. Now, the first thing that makes hesitation tricky is that people use one word for three different behaviors. One is a true misfire, the engine stumbles and feels rough, often worse under load, sometimes with a flashing light. Another is a lean tip-in flat spot, you touch the throttle and it falls on its face for a moment, then catches up. The third is surging or hunting at steady speed, you're holding the pedal steady and the car gently speeds up and slows down like it can't decide. Those three can overlap, but they point you toward different checks. So I want you to picture your hesitation like a pattern, not a mystery. When does it happen? Only when cold, only when hot, only at light throttle, only when you flow it, only uphill, only with the AC on, only right after refueling. Does it happen at a specific RPM range? Does it feel like one clean, dead spot, or like repeated jerks? Does it improve if you lift off slightly? These details matter more than the part you're tempted to buy. Here's the paradox that catches people: if the engine is starving for fuel, why do so many real fixes start with air leaks, sensors, and ignition? Because fuel delivery problems that are bad enough to cause hesitation under load often show up in a very specific way, and they're not the most common first failure. Meanwhile, a tiny unmetered air leak, a dirty airflow signal, or a weak spark can create a lean condition or incomplete burn that feels exactly like fuel starvation. The engine doesn't care what you call it, it just knows the torque didn't arrive when you asked for it. Let's map the symptoms to likely directions. If it hesitates mostly at light throttle, like when you're creeping in traffic or gently accelerating, and it feels like a soft flat spot rather than a violent shake, that often points to airflow measurement, small vacuum leaks, throttle body issues, or adaptation problems. If it hesitates mostly when you ask for power, like uphill or when you press deeper, and it feels like a stronger stumble or repeated jerking, that pushes ignition breakdown under load, fuel pressure delivery limits, or sometimes exhaust restriction. If it's worse when the engine is hot, coils and sensors become more suspicious. If it's worse when cold and then cleans up, think about intake leaks that seal when warm, coolant temperature reading issues, or deposits and idle control behavior. If it started right after you refueled, don't ignore the obvious: bad fuel happens, and also EVAP purge issues can dump vapors at the wrong time and cause a stumble. Now we move into the practical path, because the goal is not to become a full-time diagnostician. The goal is to stop guessing. And this is the moment to say it clearly: Suzuki Swift is hesitating doesn't automatically mean replace the fuel pump. It means you start with the checks that are cheap, fast, and most likely, and you only climb the ladder when the evidence forces you. Start with air, because air problems are common and sneaky. Open the hood and look at the intake track like you're looking for a hole in a drinking straw. The air filter box should be closed properly. The filter shouldn't be collapsed, soaked, or packed with debris. The intake ducting between the air box and the throttle body is a classic place for cracks, especially in the folds. A crack that can open under engine movement and load, letting in air that the engine didn't measure. That creates a lean moment right when you accelerate. Wiggle the duct gently, look underneath, and check clamps. Also look for any small vacuum hoses that are split, loose, or oily and soft. If there's a PCV hose that's cracked or not seated, that's unmetered air too. People love the idea of spraying cleaner around the engine to find a leak by listening for RPM changes. Be careful with that. Spraying flammable stuff around a hot engine is not a game. If you don't have a smoke machine, a safer approach is visual inspection plus listening for hissing, plus watching fuel trims on a scan tool if you have one. Even without a scan tool, you can sometimes find a leak by feel: a hose that's not connected, a boot that's torn, a clamp that's loose. Next, throttle body condition and throttle learning. A dirty throttle body can cause weird tip-in behavior because the throttle plate doesn't respond smoothly at tiny openings, and the ECU is constantly trying to hit a target airflow. Cleaning can help, but it's also a place where people create new problems. If you scrub aggressively, force the plate, or soak electronics with the wrong chemical, you can end up with a worse idle or a new hesitation. If you choose to clean it, use proper throttle body cleaner, be gentle, and don't flood sensors. And understand this, after cleaning, or after a battery disconnect, some cars need a relearn or adaptation process. If the idle is unstable or the throttle response feels odd right after work, it might not be broken, it might be not learned yet. The exact procedure varies, so don't invent one. Sometimes a few normal drive cycles help, sometimes a scan tool adaptation is needed. Now ignition, because spark is the number one feels like fuel culprit. Spark plugs are boring until they're not. A worn plug can fire fine at idle and light load, then fail under cylinder pressure when you accelerate. That's when you feel the hesitation. The trap is that the car can still start easily and idle smoothly, so you assume plugs are fine. But under load, the voltage demand rises, and weak components show themselves. If you don't know when the plugs were last changed, that's a strong candidate for a first real maintenance step. But don't just throw in any plug. Wrong heat range, wrong type, wrong gap, or low-quality plugs can create their own drivability issues. If you replace plugs, match the correct specification for your engine and don't assume pre-gapped means correct. Also, be careful with over-tightening or cross-threading. If you're not comfortable, this is a good point to involve a mechanic, because a damaged thread is a much bigger problem than hesitation. Coil packs are the next suspect. Coils can break down with heat and load. A classic pattern is, it drives okay when cold, then starts hesitating after 10 to 20 minutes, especially on acceleration. Another pattern is, it hesitates only when you push it, but cruises fine. If you have a scan tool that shows misfire counts by cylinder, that's gold. If you don't, you can still do a basic logic test. If you get a misfire code for a specific cylinder, swapping that coil to another cylinder and seeing if the misfire follows is a common diagnostic method. It's not perfect, but it's better than guessing. Just remember that aftermarket coils can be hit or miss. Replacing a good factory coil with a questionable new one is a real way to chase your tail. Now sensors, because modern engines run on signals, and a slightly wrong signal can feel like a mechanical failure. Depending on the Swift engine and year, you'll typically have either a MAF sensor, a MAP sensor, or both. A MAF that underreports airflow will make the ECU inject less fuel than needed, especially during quick throttle changes. That creates a lean hesitation. A MAP sensor that reads wrong can do similar things, especially in speed density strategies. Cleaning a MAF can help if it's contaminated, but again, this is a place where people cause damage. Only use proper MAF cleaner, never touch the sensing element, and don't use brake cleaner or carb cleaner on it. If you're not sure what sensor you have, don't spray random parts. Also check connectors. A slightly loose connector at the MAF/MAP, throttle body, or coils can create intermittent hesitation that comes and goes with vibration. Look for broken locking tabs, corrosion, or wires pulled tight. Sometimes the fix is literally reseating a connector properly. Battery and charging health sounds unrelated, but low voltage can cause weird throttle and ignition behavior, especially at idle with loads like AC, headlights, rear defrost. If the hesitation is worse with AC on, don't jump straight to fuel pump. Make sure the engine isn't struggling because the idle control is compensating for load and the electrical system is weak. You don't need to become an electrician, but if the car cranks slowly, lights dim, or you've had battery issues, keep it on the radar. Fuel quality and EVAP behavior deserve a quick reality check. If the hesitation started immediately after refueling, and especially if it's accompanied by rough running or hard starting, consider the possibility of contaminated fuel. The other angle is the EVAP purge valve. If it sticks open, it can introduce fuel vapors at the wrong time, leaning or enriching the mixture unpredictably. That can cause a stumble at idle or light throttle. It's not the first thing to replace blindly, but it's a known pattern, weird drivability plus refuel timing. Now, if you can access an OBD2 scanner, even a basic one, you can stop guessing much faster. You don't need a fancy tool. Codes are helpful, but live data is where the story is. Start with codes and freeze frame data if available. AP0300 random misfire or P0301, P0304 cylinder specific misfire points you toward ignition first, then injector, then mechanical. Lean codes like P0171 suggest the engine is running lean, but that doesn't automatically mean fuel pump. It often means unmetered air, MAF underreporting, or a vacuum leak. Rich codes point to different issues, like leaking injectors, fuel pressure regulation problems, or sensor bias. Now fuel trims, STFT and LTFT. Think of STFT as the ECU's immediate correction and LTFT as the learned correction over time. If both trims are significantly positive at idle and improve when you raise RPM, that often suggests a vacuum leak, because vacuum leaks matter most at idle when airflow is low. If trims are positive across the board and get worse under load, that can suggest fuel delivery limitation or MAF underreporting. If trims are negative, the ECU is pulling fuel, which can point to rich conditions, leaking fuel, or sensor issues. If you can watch O2 sensor behavior, you're looking for whether it's switching normally in closed loop at steady cruise. A lazy sensor can contribute, but it's rarely the first cause of a sharp hesitation. More often, the O2 sensor is reporting the result of another problem. Coolant temperature reading is another quiet killer. If the ECU thinks the engine is colder or hotter than it really is, it will fuel incorrectly. If your scan tool shows the engine never reaching normal temperature, or the reading jumps around, that's a clue. Again, not a guarantee, but a clue. Throttle position and commanded throttle can help you separate driver request from engine response. If you press the pedal and the throttle command changes smoothly but the engine stumbles, that points away from pedal sensors and toward air/fuel/spark. If the throttle command itself is erratic, you might be dealing with throttle control issues, pedal sensor issues, or wiring. Now, the big one people miss, fuel pressure under load. A fuel pump can be weak and still show okay pressure at idle. The real test is what happens when you demand flow. If you have access to a proper fuel pressure test, you want to see where the pressure holds when you accelerate. If it drops, then yes, fuel delivery becomes a prime suspect, pump, filter if serviceable, pressure regulator depending on design, or even electrical supply to the pump. But don't assume. Test if you can, or have it tested. Injectors are another expensive rabbit hole. A partially clogged injector can cause a cylinder-specific lean misfire, often showing as a specific misfire code. But injectors are dirty is also the most overused explanation for everything. If you have a cylinder-specific issue and ignition checks out, then injector testing makes sense. If the hesitation is general and there are no misfire clues, injectors are not the first place to spend money. Exhaust restriction, like a clogged catalytic converter, can mimic hesitation too, usually with a different feel. The car feels like it can't breathe, power falls off at higher RPM, and it may get worse as things heat up. Sometimes you'll hear unusual sounds or notice excessive heat. This is not a DIY guess and replace item. It's a test and confirm a situation. Now let's talk about the automatic or CVT angle, because some people describe transmission behavior as hesitation. If the engine revs but the car doesn't accelerate proportionally, or it feels like a rubber band effect, that can be transmission related. But true engine hesitation usually comes with a change in engine smoothness, not just vehicle speed. If you can reproduce the hesitation in neutral by gently blipping the throttle and it stumbles, that's engine side. If it only happens under load in gear and the engine seems smooth, then you consider drivetrain and transmission behavior. Still, don't jump to worst-case scenarios. Many transmission hesitations are actually engine torque interruptions from misfires or throttle control. So what's the smartest fix strategy that doesn't waste money? You start with the things that are both common and verifiable. Intake ducting and vacuum leaks. Air filter and airbox sealing. Connector checks. Battery health if there are signs. Then ignition maintenance, correct plugs, and coils if there's evidence. Then sensor sanity, MAF/map cleanliness and plausibility, not aggressive cleaning and not random replacement. Then, and only then, you move into fuel delivery testing under load and injector diagnostics. And you verify each step with a repeatable road test. Same stretch of road, same gear, same throttle input. Hesitation problems love placebo repairs because they can come and go with temperature and driving style. If you change 3 things at once and it feels better, you don't know what fixed it, and you can't learn from it. One change, one test, one conclusion. Here are a few common pitfalls that create new hesitation after you try to fix the old one. Installing the wrong plugs or gapping them incorrectly. Damaging a coil boot or not seating it fully. Cracking an intake hose while you're moving it around. Overcleaning a MAF or throttle body and leaving residue. Forgetting to reconnect a vacuum line. Leaving a clamp loose. These are boring mistakes, but they're exactly how a simple job turns into a week of frustration. Now, when should you stop and hand it to a professional? If the check engine light is flashing. If you have persistent misfire that doesn't respond to basic ignition checks. If fuel pressure testing is needed and you don't have safe access to the equipment. If you suspect catalytic restriction. If the car is stalling in traffic or feels unsafe to drive. A good shop can do smoke testing, scope ignition patterns, and measure fuel delivery properly. The key is you'll arrive with a clear symptom description and a list of what's already been checked, which saves time and prevents random part swapping. And here's the final clarity I want you to leave with. When Suzuki Swift is hesitating, the winning approach is not to pick your favorite theory. It's to classify the hesitation pattern, start with air and spark because they fail quietly and often, use OBD2 data if you can to see whether the engine is adding fuel or pulling it, and only then chase fuel delivery with real testing under load. Most of the time, the fix ends up being something unglamorous, a cracked intake boot, tired plugs, a coil that breaks down when hot, a dirty or misreporting airflow signal, or a throttle body that needs cleaning and proper adaptation. And once you confirm the repair with the same road test that used to trigger the stumble, you're not just relieved. You actually know why it happened, which is the only real way to keep it from coming back. If you want a simple way to describe your issue to a mechanic or to your future self, write down 3 things: exactly when it hesitates, whether the engine feels rough or just flat, and whether any light flashes. That little note turns Suzuki Swift is hesitating from a vague complaint into a solvable problem.